The order of operations dictates the sequence in which mathematical operations should be performed. This sequence is often remembered using the acronym PEMDAS, parentheses, exponents, multiplication, and division, left from left to right, addition and subtraction from left to right. So you want to do everything in order. So parentheses come first, so you have to do whatever's in the parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. To simplify mathematical expressions, combine like terms and apply the order of operations. So like I said, parentheses first, and then exponents, then multiplication, then division, then addition, then subtraction. This leads to clearer and more manageable equations, making calculations more straightforward and interpretable. Fractions represent parts of a whole, while decimals explain the same concept in a base 10 format. Understanding how to convert between fractions and decimals is foundational for both arithmetic operations and real-life applications. Percentages express a number as a fraction of 100, making it easier to compare relative sizes. Converting between percentages, fractions, and decimals is crucial for solving many business and personal finance problems. The average is calculated by summing values and dividing them by their count, reflecting a central value. A weighted average gives different weights to values useful in financial contexts where certain factors are prioritized. Payroll calculations determine gross earnings based on salaries, wages, and commissions. Accuracy in these calculations is essential for maintaining employee satisfaction and ensuring compliance with financial regulations. Understanding tax applications such as PST, GST, and HST is vital for compliance and financial planning. These taxes affect both personal and business transactions, impacting total costs and profit margins. A ratio represents a relationship between two quantities expressed as a fraction, with the first quantity as the numerator and the second as the denominator. For example, if there are 3 apples and 2 oranges, the ratio of apples to oranges is 3 to 2. Proportions are equations that state two ratios are equivalent. They can be used to solve for unknown values in various applications. For instance, if 5 pencils cost $3, how much would 8 pencils cost? Setting the proportion allows for easy calculations. Currency conversions involve the use of ratios to compare different currencies. For example, if 1 USD is equivalent to 0.85 EUR, then to convert 100 USD to EUR, multiply by the exchange rate, resulting in 85 EUR. Percentages express a number as a fraction of 100 and are particularly useful in comparing sizes or quantities. For example, a 20% discount on a $50 item reduces the price by $10, making the final cost $40. Increase and decrease problems involve calculating change value based on the percentage. For example, if a price increases from $100 by 15%, the new price is $115. Conversely, a decrease of 15% would result in a price of $85. Algebraic expressions can be simplified using operations like addition, subtraction, multiplication, and division. For instance, combine like terms in the expression 3x plus 2x to get 5x, making further calculation more straightforward. Exponents are used to express repeated multiplication. For example, 3 squared equals 9, while 2 cubed equals 8. The rules of exponents also include handling negative exponents and zero exponents, which is essential for simplification. Basic equations can be solved using inverse operations. For example, to solve 2x plus 3 equals 7, subtract 3 from both sides, and then divide by 2, resulting in x equals 2. This process is foundational for more complex equations. Translating word problems into equations is crucial for solving them. For example, if the rectangle's length is twice its width and its total perimeter is 36, set up equations, find dimensions. This practice bridges algebra with real-world applications. Linear systems can be solved using graphical methods where equations like y equals 2x plus 1 can be represented visually. The intersection points of the graphs represent solutions to the system. Systems of inequalities. Systems of linear inequalities can be graphed to find feasible regions representing solutions. For example, graphing y is less than 2x plus 3 will shade all points below the line, showcasing possible solutions satisfying the inequality constraints. Statistics provides a way to collect, analyze, interpret, and present data. It offers essential tools for making data-driven decisions in various fields, including business, healthcare, and social sciences. Measures of central tendency, including mean, median, and mode, help summarize data. These averages provide insight into the typical values within a data set, crucial for interpreting business metrics. Data distributions show what values are spread across the data set. Understanding normal distributions helps identify trends and deviations, essential for quality control and forecasting a business. Graphical representations like bar charts, pie charts, and histograms visualize data effectively. These tools facilitate comparisons, making complex data more understandable for stakeholders. Cost volume profit analysis examines how changes in cost and sales volume affect profits. This analysis helps businesses make pricing decisions and evaluate operational efficiency. Time value of money concept asserts that a dollar today is worth more than a dollar in the future due to potential earning capacity. This principle is foundational in financial decision making and investment planning. Investment calculations involve determining potential returns based on interest rates and time periods. Knowing how to calculate competitive returns is essential for assessing investment opportunities accurately. Calculating present and future values allows businesses to assess the value of cash flows over time. The formulas help in making informed investment decisions and understanding of profitability over periods. Algebra is a branch of mathematics that uses symbols and letters to represent numbers and quantities and formulas and equations. It allows for the manipulation of mathematical expressions to solve problems systematically. Algebra is essential in mathematics as it lays the groundwork for advanced studies in fields such as calculus, statistics, and engineering. It helps in developing critical thinking and problem-solving skills applicable in various disciplines. Key terms in algebra include variables, which represent unknowns, constants, which are fixed values, and coefficients, numerical value factor in a term. Understanding these elements is fundamental to mastering algebraic expressions and equations. Algebra can be categorized in various types. Elementary algebra focuses on basic operations and functions. Abstract algebra deals with structures like groups and rings, and linear algebra concerns vector spaces and linear transformations. Each type serves different applications of mathematics. Algebraic expressions are formed by combining variables, constants, and arithmetic operations. For instance, 3x plus 5 is an expression where x is a variable, 3 is a coefficient, and 5 is constant. Mastering these components is essential for creating accurate mathematical representations. Simplifying algebraic expressions involves reducing them to the simplest form, allowing for easier computation. Techniques include combining like terms and applying distributive property. For example, 4x plus 2x simplifies to 6x, demonstrating organization for clearer problem solving. Evaluating algebraic expressions means substituting values for variables and performing basic operations. For example, if x equals 2 in the expression 3x plus 4, the evaluation yields 3 times 2 plus 4 equals 10. This process is fundamental for solving equations and understanding algebraic relationships. An algebraic expression expresses the equality of two expressions, typically involving variables. The goal is to find the value of the variable that makes the equation true, forming the foundation for all algebraic problem solving. Common methods for solving algebraic equations include substitution and elimination. The substitution method involves replacing a variable with an equivalent expression, while elimination focuses on removing variables through addition and subtraction methods. Simple linear equations can be solved using basic methods. For example, in the equation 2x plus 3 equals 11, subtracting 3 from both sides and dividing by 2 gives x equals 4, demonstrating a straightforward approach to algebraic solutions. Quadratic equations take the form ax squared plus bx plus c equals 0, with solutions derived using factoring, completing the square, or the quadratic formula. These equations represent parabolas in graphical form, illustrating the relationship between variables. In everyday life, algebra is used in budgeting, cooking, and project planning. For instance, when creating a budget, variables are often used to represent income and expenses, helping individuals allocate resources more effectively. Algebra is foundational in fields such as physics and engineering. It helps in formulating equations that describe real-world phenomena, such as motion and the behavior of electrical circuits. In technology, algebra is applied in programming to develop algorithms. Data analysis also relies on algebraic models to interpret data sets and draw conclusions, making it essential in business intelligence. Algebra is integral to everyday decision-making, scientific investigations, and technological advancements. Its applications are vast, from personal finances to complex engineering problems, underscoring its importance in various sectors. So the next thing we will do is we're going to cover this here. So we're going to just go through these questions and how to solve them step by step. So for the first one here, the answer is located at the bottom here. But what we'd have to do to find this answer is we take this expression here. So copy this expression, copy, paste, and then we'd have to do the what's in the brackets first. So with 12 times 5, that equals 60. And then 8 minus 4 here would just be 4. So we do that. We get what's in the brackets. So now the brackets will be 60 divided by 4 plus 6. And then we have to divide here. 60 divided by 4 is 15 plus 6. And then we would get 21 in this case. So the correct answer is actually 21 in this case. So A, 21 is the right answer. And then the next question here, a teacher is contracted to teach 18 credit hours per week in a semester-based school. Any hours above this are considered overtime, paid at 1.5 times the regular rate of $32.45 per hour. Teacher worked the following hours per week for a 16-week term. How much total overtime pay is owed at the end of the term? So to do this, we would have to take the term length is 16 weeks, and they're due to do 18 credit hours per week. So here, every week they do the 18. They do at least 18 every week times 32.45 equals, so 18 times 32.45. We would get 584.10. So that's the non-overtime pay. And then we'll calculate how much overtime we have here. So in this case, the total here, in this case, to figure out the per hour overtime to pay, we do 32.45 times 1.5, and then we get 48.675 would be the overtime pay per hour. And then if we calculate how much overtime hours there are, so we'd have to subtract each of these by 18 to get the amount of overtime hours. So in this case, it'd be 22 minus 18 equals 4. 21 minus 18 equals 3. Then 23 minus 18 equals 5. 20 minus 18 equals 2. 25 minus 18 equals 7. 19 minus 18 equals 1. 22 minus 18 equals 4. And so on. 21 minus 18 equals 3. 20 minus 18 equals 2. And what we'll do is just so we're able to see it all here, we will just kind of put a lot of it on the same line here. So 20 minus 18 we did equals 2. 24 minus 18 equals 6. 21 minus 18 equals 3. 23 minus 18 equals 5. 22 minus 18 equals 4. 20 minus 18 equals 2. 19 minus 18 equals 1. 24 minus 18 equals 6. So if we add all that up, we would get approximately 58 hours. So we add up all the differences, we get 58 hours of overtime pay. So then to get the amount of overtime pay, we multiply the 48.675 times the 58. And let's do that. So it would be 48.675 times 58. We do that, and let's see what we get out of that. We would get so in this case, it would be none of these options. So we'll just take this out. It would be none of the options here. It turns out it'll be none of the above. So the answer will be 2,823.15. So we get that as our answer here. And yeah, we'll just keep going here. So then the 3 here, person earns a gross salary of $25,750. Employment insurance is deducted at 1.95%. Canadian pension plan at 4.25%, and income tax at 19% on all amounts exceeding $10,000. What is their net salary after deductions? So this is a good calculation because you have to make all those deductions when you're paying taxes. So for the employment insurance, we do the 25,750. We multiply that by the 1.95%, which is, so we do that, and then we'll get 500, 1.13. So we have to take that deduction, and then we got to take the Canadian pension plan deduction again. So we do this as well for any salary we earn. We have to deduct all these things. So 25,750 times 4.25%, we get 1,099.38. And then the next one, we would do taxable income. We do 25,750 minus the 10,000. That's recorded in the question. We get 15,750. Then income tax, we'd multiply that 15,750 times 0.19, and then we get 2,992.50. And then net pay calculation, it would be 25,750 minus 500, 1.13 plus 1,009.38 plus 2,909.2.50. Then we get 21,161. So that's how we would do that. So make sure to use these brackets, and that would be the answer, 21,161. And then for 4 here, solve this one. It's very similar to what we did in 1. So we got to divide 144 divided by 12 first. We get 12. Then we do 8 minus 6, which is 2. And then we do 12 divided by 2, and we get 6. So 12 divided by 2 to get 6 here. So in this case, it's multiplying here. So we have to multiply instead. So 8 minus 6 is 2. 12 times 2 is 24. 24 plus 5 is 29. So that's how we would do that there. And then for 5 here, you purchased a laptop in Ontario for $1,695, including HST. What is the total amount of HST paid? So what we'd have to do for this, we'd have to take the 1,695 times the 13% HST, and then we get 220.35 would be the answer. Yeah. So we get that here. And then the next one here, in remote camp, 8 workers have enough food rations for 4 days. If 2 workers leave, for how many days will the remaining rations last? So what we'd have to do is, so new days would be initial workers times initial days divided by remaining workers. So we would do that. So in this case, it would be the 8, so initial workers be 8, initial days be 24, remaining workers would be 6. So we put all that in. 8 times 24 divided by 6 equals 32 here. So we get that as the answer. So it'd be 32 days. Yeah. So we'll get to the next one here. So convert 15% into a fraction. So how we do that is, sorry, 0.15% as a fraction. So how we do that is putting this into a fraction, 0.15%. That's the same as 0.0015. So that's how it converts to a decimal. You have to put 2 zeros in front because it's a 0.15 decimal. So you do that, and then we can create a fraction from that. So 0.0015, that's the same as 15 divided by 10,000. So we can do that to start. So that would be a potential fraction we could use here. We do 15 divided by 10,000, and then we can maybe change it to 30 divided by. So we can multiply top and bottom by 2, and we get 30 divided by 20,000. So we could multiply top and bottom by that. 30 divided by 20,000, and then we can take away one of the zeros, so it'd be 3 divided by 2,000. So that could be the fraction there. So so there's many fractions you could do, but that could be one option. So for question 8 here, you sell a house 96.2% of the listing price, and the sales commission rate is 4.2%, and the listing price was $275,000. How much is the commission? So how to do this? We would have to just multiply everything here. So we would take the $275,000 times 96.2% times 4.2%, and then we'd be getting 11,097.50. And I'll show this in decimals. 27500 times 0.962. This is the same thing times 0.042. So that's how you write it in decimals instead of fractions, but it gives you the same result. That's just how decimals are. You got to just divide percent by 100. You get the decimal, and then you get roughly 11,111. So roughly 11,111.1. So that's how you would do that there. Yep. And then $220, what percentage less than $400? So how you do this is you do original price minus new price divided by original price times 100%. And so you do that, and it would be 400 minus 220 divided by 400 and times 100%. And then you would get 45% here. So that would be how you do that one. Yeah, so that's how you do that one here. And then the next one. The next one here. So question 10. You're exchanging US dollars to Canadian dollars before flying home. The exchange rate is 1.0325 per USD, and the money exchange shop charges a 4% commission. How many Canadian dollars will you receive for $450? So how to do this is you would take the $450 times that by the exchange rate of 1.0325, and then you get 464.625. So that's CAD here. So that's how you convert it from US to Canadian dollars here. So that's how you do that. And then that's how you get that. And then apply commission. So 464.625 times the commission times 1 minus the commission of 4%, which is 0.04. Then you get 432.99 CAD. So that's how much you have. This is how much you have after you pay the commission. So like we said before, 0.04 equals 4%. So this is how much you have after paying the commission.